Hello, let's continue our Sudoku adventure with Squares by Jaze. So this is the final puzzle of our Counting Circles theme week. I hope you enjoyed it. I'm sure we will have more counting circle puzzles in the future, but it won't be all of them. All right, so what are the rules to this final puzzle? Well, we have normal 6x6 Sudoku rules, so in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have counting circles in the grid. Those are these circles here. The way counting circles work is if a digit appears in a counting circle, like say a 3, then exactly that number of 3s must appear in circles. So something like this. So here we have 3 3s that appear in circles, if we're assuming none of these end up 3s. If I tried to put another 3 here, that would break the rules because there'd now be 4 3s in circles. Or if I have only 2 3s, I need to make sure I put one more in there. So there'll be exactly 3 3s in circles if a 3 appears in a circle at all. Obviously, if it doesn't appear in a circle, then it's not in circles at all. Okay, we also have inverse counting squares. So it's kind of the inverse of circles, but pay attention to the rules carefully. They can be easily misunderstood. So a digit in a square indicates exactly how many times that digit appears in non-square cells. So if I have a 3 in a square, what that means is in cells that aren't squares, so any of these cells that aren't squares, the 3 is going to appear 3 times. So this 3 in the square doesn't count towards that count because it's in a square. We need to count how many 3s appear in these cells, and it's going to be exactly 3. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, I'm going to start with the circles because that's a bit more clear how to start. So we're going to count the circles. It looks like there are 1, 2, 5, 6, 7. There are 7 circles in the grid. So what I will tell you is that the unique digits that appear in circles sum to 7. And the reason we know that is if I have, say, a 5 in a circle, then 5 other circles exactly will also be 5. I don't think we can do that in this puzzle, but anyway, it doesn't matter. What matters is that the 5 utilizes 5 of the circles, and a 3 would utilize 3 of the circles, right? So if this is utilizing 5 of the circles, and this is utilizing 3 of the circles, in total, now I know that we've utilized 8 circles. And if another digit appears in there, it utilizes that many. So if a 1 were to appear here, now I would be utilizing 9 circles, right? So if we take the unique digits that appear in all the circles and we sum them up, those are going to sum to 7 because there are exactly 7 circles. So let's think about this row here. This row has 3 unique digits in circles. And so how do we get 3 unique digits to add to 7? Well, the answer is only 1, 2, 4. We cannot have the digits, we can't have 4 unique digits because that they would add to a minimum of 10. 1, 2, 3, 4 is 10. So this is 1, 2, 4. That's not 4. And so now we know that the circles, we've already utilized the 1. It already appears once. And so the remaining circles are from 2, 4. And one of them will be 2, which is this one. And the rest of them will be 4 because we can't have any more 2s. So that makes that a 4. All right, that's good progress. Let's pencil some cells at least. So we've got 3, 5, 6 here, 3, 5, 6 here. That's not 6. This is 1, 2 pair. That resolves. Nice. Okay, so we got a 2 in a square. Because a 2 appears in a square, that means we have exactly 2 2s in non-squares. There's a few ways we can think about it. First of all, we already have identified them. Those are the 2 2s in non-squares, which means I need the rest of the 2s to be in squares. The other way to think about it is we can kind of inverse the rules and say, well, if a 2 appears in a square, then 6 minus 2 2s appear in squares because 2 of them will be in non-squares, which means the rest of the 2s in the whole grid will be in squares. So we need 4 2s in squares for 2 different reasons, or maybe the same reason, but seen 2 different ways. So how do I get 3 more 2s? Well, this can't be a 2. So this is a 2, this is a 2, and this is a 2. Okay, so that's what has to happen. These are all 2s. That's a 1 and a 2. Okay, we can never have a 6 in a square because a 6 in a square is saying that there are now 6 6s not in squares, but one of them is definitely in a square because we just put it there. So we can't put a 6 here or here. So this ends up a 6. That ends up a 6. Okay, so we definitely have a 3 and a 5 in squares. So the 5 in squares is telling us that there is only one 5. So we can't have another 5 in the square, or we'll end up with only 4 5s in non-squares. And so this is a 3. And the 3 is telling us that we need 3 3s in squares. So that's a 3, that's a 5, that's a 3. Nice. And now we should just be able to plonk digits. So this is, we need a 3 in this column. We also need a 5. We get a deet deet doot in the corner. Nice. These are from 156. You can clean that up a little bit, but it's not completed. This is also 156. It's not a 5, so it's 1 6. This is 1 6. This is 1 5, but it's not a 1, so that's 5 and 1. That's 6 and 5. That's 1 and 6. I mean, this is a 3 for the column. Here we need a 1 and a 3. We know the order because of this 3. And then in this box we need, well, let's just do the roping. We need 1 and 5 down here. That's 1 5. And then we need 4 and 6 here. That's 4 and 6. And we're done. Nice. I think a 1 goes in that circle. All right. Okay, cool. Nice puzzle, Jaze. That was a neat idea for having the inverse counting squares. I don't think Jaze invented it, but it was a nice application of it. I hope the wording was clear. We had a lot of discussion about how to word the rules for that. So I hope that worked out for you. And I hope my explanation was clear. I hope you enjoyed this theme week. I think it was a fun theme week. Really nice use of the counting circle idea. And I enjoyed this puzzle as well. So thank you, Jaze. I hope you did too. And if you did, then why not leave a like, subscribe, and a kind comment below.